Okay, friends, so I'm feeling pretty good about how to find the percent that's represented when you have a part and a whole. Start with the part, divide it by the whole, and that gives you the percent. Actually, that right there would be a per one, but we took care of that by moving the decimal point 2 places to the right to turn it into an actual percent. And that's great, but sometimes you don't know the part and the whole. You might know only one, but you also know the percent. From just this information, can you figure out what the part is?
And the answer, absolutely. You totally can. So if you know the percent and you know the whole, for example, you can find the part. And here's something you probably learned a long time ago. First of all, notice that the percent looks like it's floating in space. Just like we spoke of before, it really has a 1 under it. This is now known as a proportion because you've got a fraction equal to a fraction. This is a good thing because of something else you learned a long time ago. In any proportion, the diagonal numbers multiplied on one diagonal equal the diagonal numbers on the other diagonal. So 1 times that question mark is just going to be the question mark, and this is going to be equal to the percent times the whole. Now, one of the things that kind of sits well with this is these kinds of problems are often expressed as what is, say, 18% of 50. As a matter of fact, let's go do that one right now.
Yeah, this would be a good place to start. Okay, what is 18% of 50? Okay, so using the model we just spoke of, we're going to take that 18% and we're going to multiply it by that 50. Now remember that 18% is actually 18 over 100. And honestly, I make this even easier on myself by dividing that 18 by the 100 and making 0.18. And from there, my friends, we just run it through our favorite calculator and see what the result is. So there you have it, my friends. 18% of 50 is 9. And the best part is, this same procedure works for any problem like this. Let's try another one. Oh, I don't know, how about 87% of 62.3? Why not? I'm going to start by converting that 87% to 0.87, and then that of implies a multiplication, and the whole is to 62.3. Then we head to our favorite computation machine, and we find out that 87% of 62.3 is about 54.2. And there you have it. Let's do one more with a percentage that oftentimes will get students a little confused. Let's find 0.35% of 216. Now, the reason students sometimes get freaked out about this is because that decimal is in a place they don't expect it to be. But here's the thing. All that decimal being there means is this is less than 1%. And that's the only thing you have to think about. Actually, you don't even have to think about that. It's the same procedure from before. Take the percent, change it to a decimal by moving the decimal point 2 places to the left. That will become 0.0035. Of means to multiply, and the whole is the 216. Let's go crunch the numbers, and we see that 0.35% of 216 is about equal to 3/4. 0.756.
Okay, my friends, this brings us to the end of Percent Bootcamp. It was just designed to kind of tickle the back part of your memory and kind of bring back some ideas I'm sure that you learned at some point. Some of this you might not even find yourself using because as technology gets better, you can just simply ask Google how to do some of these questions. Like that last one we just did. You can just type it in and ask it and it'll tell you. But the idea was to kind of go back in and look at why the numbers are the way they are. So hopefully that helped. Also, as you move through your next few math classes, the percent problems that you'll be doing won't be as straightforward as the ones we just did. Like, you're not going to have a test that simply asks what is, 12% of 80. That's going to be within other problems. Generally speaking, pulling numbers from graphs or pulling numbers from verbal statements. So the idea was when you get to that point, you want to be able to extract the math that you have to do from the problem and then be able to do it with the techniques from these videos. So in that, again, I hope it helped in that respect. If you ever find yourself with more questions on percentages or their applications, my email's right there. Feel free to reach out. Just let me know who you are if I don't know you. And otherwise, yeah, I hope this was helpful, and be well and good luck.